Look up at the sky on a clear day. You feel the warmth on your skin. What you are actually feeling is the energy of a continuous, unimaginable nuclear explosion happening 93 million miles away. For most of human history, if we wanted to harness energy, we had to destroy something. We had to dig into the earth, extract wood and coal, and burn them. When we found liquid fuel, extracting it was often a chaotic, messy eruption, forcing raw energy directly out of the ground. Even as our technology advanced, generating power remained intensely physical. We boiled water to create steam, using that immense pressure to violently spin massive, heavy metal turbines. We built our modern world on the assumption that generating raw electrical power naturally requires loud, dirty, and violent mechanical motion. But then, look at a modern solar panel resting quietly on a suburban roof. It sits there, completely frozen, simply baking in the sun. It makes no sound. It has no exhaust pipe. It has 0 moving parts. Yet from that silent, flat rectangle of glass and metal, enough raw electrical power flows out to drive a 2-ton car at highway speeds. How do we catch invisible light from a star and turn it directly into a massive flow of electricity without a single moving gear? To find out, we have to dive down to the atomic level. To understand the trap we build inside these panels, look at this pure silicon crystal. At the atomic level, it is a perfectly rigid, symmetrical structure. All of its electrons are locked tightly in place. Electricity is, by definition, the movement of electrons. Because pure silicon refuses to let its electrons move, it is actually a terrible conductor. To make the silicon work for us, scientists have to intentionally break its perfection. They contaminate it through a precise chemical process called doping. First, they slice the silicon into incredibly thin layers. In the top layer, they mix in a tiny bit of phosphorus.
Phosphorus has extra electrons, which makes this entire top layer chemically desperate to give away negative charge. We call this the N-type silicon. In the bottom layer, they mix in boron. Boron is completely missing an electron. It has empty space, or holes. This makes the bottom layer chemically desperate to absorb a negative charge. We call this the P-type silicon. By intentionally breaking nature's symmetry, human engineering creates an extreme chemical imbalance, setting the stage for a microscopic energy trap. The trap arms itself the exact moment these 2 chemically desperate layers are pressed together. Instantly, the extra electrons from the top layer rush the border to fill the empty holes in the bottom. As they lock together along that dividing line, they form a permanent, invisible wall. We call this barrier the p-n junction. It is a primed electrical force field, sitting completely still directly in the middle of the panel, waiting for a trigger. That trigger begins deep inside the core of the sun, where hydrogen atoms smash together to release packets of pure energy called photons. A single photon escapes the sun's gravity, travels 93 million miles through the absolute zero vacuum of space, and strikes the panel. Now the game of cosmic billiards begins. The photon acts exactly like a cue ball in a game of pool. It crashes into the silicon lattice, violently knocking a single electron out of its bond. The freed electron tries to move, but that glowing central force field, the p-n junction, forcefully repels it. It bounces off the barrier, trapped strictly in the top layer. Now multiply that impact by millions of photons striking the panel every single second. Millions of electrons are knocked loose and pushed upward, building a massive, desperate pressure at the top of the panel as they try to return to the bottom to find balance. Because that central force field acts as a one-way wall, the electrons cannot simply sink back down through the silicon. So human engineering gives them an escape route: ultra-thin, highly conductive silver wires. But we don't just let them run straight home. We hijack their journey. Before the wire connects back to the bottom of the panel, we force those rushing electrons to push their way through the circuits of your television, your microwave, and your light bulbs. We don't truly generate energy inside a solar panel. We simply build an intelligent detour for a cosmic particle desperately trying to find its way home. Once the electron finally reaches the bottom layer, the system instantly resets. It sits in total silence, waiting for the next photon from the sun to knock it loose again, repeating the cycle billions of times a second. A single tiny cell only moves a microscopic amount of electrons.
But when you wire millions of them together, you get vast solar farms capable of powering entire cities. The photovoltaic effect takes the terrifying, explosive nuclear violence of a star, captures its light after an 8-minute journey across the void, and translates it directly into the invisible power that runs the modern world.